What's going on, guys? Welcome back to the channel. Today we're going to be going through the hardest questions of the October-November 2021 paper. Okay, so these are the questions that, at least according to the examiner report, came up as being less than satisfactorily answered in most cases, whether with the most slip-ups. There's about 3 questions that were key in this respect, so we're just going to going through those today in a compiled manner. If you like the video, make sure to give it a thumbs up, like, subscribe, share with your friends if you're getting value out of these videos, and I'll see you in the next one. Alright guys, for number 6, we're given the following question. It says, when a plus bx times root 1 plus 4x, okay, where a and b are constants, when that's expanded in ascending powers of x, okay, it tells us that the coefficients of x and x squared respectively are 3 and negative 6. And it wants us to therefore find the values of a and b. How do we do that? Well, we've got a plus bx times the expansion, right, of one plus 4x to the power half. Okay, and if we go back to our expansion formula here, all right, if we go to our expansion formula, what we can say is, okay, what we get is a plus bx, all right, times 1 plus half 4x, okay, plus half minus 1 over 2 4x squared. Okay, continue the expansion. And if we simplify that down, what we get is a plus bx times 1 plus 2x minus 2x squared. Okay, keep adding along. And we can therefore multiply that out now, because remember, we're trying to find a and b, right? So if we multiply this out, what we get is a plus 2ax minus 2ax squared plus bx plus 2bx squared minus 2bx cubed, okay, which results in what? We can go for, okay, a plus 2a plus bx plus 2b minus 2a x squared, right, minus 2bx cubed. Perfect. So we know that the coefficients of x here, okay, the coefficient of x is 3 and the coefficient of x squared is negative 6. Therefore, I can say 2a plus b is going to equal 3, right? And 2b minus 2a is equal to minus 6, right? Because of our x squared over here. Which means, from here, if we add the 2 together, we get 3b, right? Then a is going to cancel, equal to minus 3. Okay, 3 plus minus 6, negative 3. So therefore b is equal to negative 1. Right? B is equal to negative 1, so therefore 2a minus 1. Alright. 2a minus 1
is therefore going to equal 3. And therefore, a is equal to 2 as a result. Alright. So this is just a classic kind of example of, it's not too difficult, it's just a bit more time consuming. And you just got to refer to the equation in your formula booklet. Okay, where we got a plus bx times 1 plus and then nx. Okay, so we've got n, this is our value of x according to the formula, right? And we just plug that all in, and then we can simplify down to here, from which we can expand, factorize, and then get simultaneous equations for a and b. And we get b is equal to -1 and a is equal to 2. Okay. Right, guys, now for number 7, 7a specifically, it's given that y is equal to ln of ln x, okay? And it wants us to show that from this, that dy by dx is equal to 1 over x ln x, right? So, how do we go about doing that? Well, dy by dx, okay, knowing that y is equal to ln of ln x, it's simply just going to equal 1 over ln x. Okay, then you apply the chain rule here. It's ln of ln x, so 1 over ln x times dx of ln x, alright? And what's that going to give you then? Well, that's going to give you 1 over ln x times 1 over x, which equals 1 over x ln x, okay? Simple enough. That's the first bit for 7a. Right, guys, now for number b, we've got the following question. We've got a differential equation, x ln x plus t times dx by dt equaling 0, okay? And it's given that x equals e when t equals 2. And knowing that, it wants us to then solve the differential equation, okay, obtaining an expression for x in terms of t, right? So how do we do that? Well, what we're going to say is x ln x, okay, plus t dx plus dt equals 0. Okay, just starting off with that. We can then say, right, we've got t dx by dt here. That's going to equal minus x ln x, right? Which therefore means that dx by dt is equal to negative x ln x, right, over t. Cool. So then, moving on from here, we can then separate the variables even more. We can say that negative 1 over x ln x dx is equal to 1 over t dt, alright? And as a result, we can now integrate, right? We can say that we've got negative integral of 1 over x ln x dx here, and that's going to equal the integral of 1 over t dt over here. Brilliant. Brilliant. Now, interestingly enough, okay, we were told in the beginning that y is equal to ln of ln x, okay? Y is equal to ln of ln x. So I can say, well, now since y is equal to ln of ln x, okay, and we know that dy by dx, right, is equal to 1 over x ln x. We can say, well, therefore, what we've got here is, if we integrate, we're going to get negative ln of ln x, right, being equal to ln t plus c. Now, why have we done that? Because, as you can see, we've integrated this and we've applied the minus to it. And over here, it's just a simple case of integrating according to our ln rules. So that's ln t, right? And adding the constant of integration. But we're not done yet. Okay? It's given that x equals e when t equals 2. Okay? So now x equals e when t is equal to 2. Right? So therefore, negative ln e is going to equal ln 2 plus c. Right? And what's ln e? Ln e is 1. So you go negative ln 1 is equal to ln 2 plus c, which means that c is going to give us negative ln 2. So putting this all together now, guys, what we get is therefore ln of ln x is equal to negative ln t plus ln 2. Alright? And we can therefore say that, okay, now this is a part that's going to kind of trip people up a bit, because you've got ln of ln x, what do we do now? Well, think about it like this, right? We can say that ln x, okay, is going to equal e to negative ln t plus ln 2, right? That's going to give me e to negative ln t times by e to ln 2. Alright? Which means that ln x, alright, is going to give me what's going to equal, I'm going to have 2, okay, and we're going to have t to the minus 1, according to our exponential rules, okay? Therefore, ln x is equal to 2 over t, so therefore x is equal to e to the power of 2 over t. Okay? And that's going to be the final answer to that question. So just a recap on that, okay? Just a recap on this. We know this, and we've now been asked a differential equation. It wants us to find an expression for x in terms of t. Okay, so we lay out the equation. We then say, okay, we've got negative 1 over x ln x dx is equal to 1 over t dt. And we know that since y, okay, we separate the variables, and we also know that since y is equal to ln of ln x, what that implies, okay, is that this is going to turn into ln of ln x, okay, because this is dy by dx. And then we get this here, apply initial conditions, okay, cool, and then we just simplify from there. Okay, raise everything to e, we get to this, and then we apply the logarithm rules. Alright, and as a result, we get 2 times t to the minus 1. Okay, x equals to e to the power of 2 over t. Alright, now for number C, guys, it says, hence state what happens as the value of x, to the value of x as t tends towards infinity. So, as t tends towards infinity, what happens? Well, as t tends towards infinity, right, 2 over t is going to tend towards 0. Okay, why? Because t is increasing, t is the denominator, so the whole thing goes towards 0. Simple enough. And so what we can then say is that the limit as t approaches infinity, okay, of e to 2 over t, well, that's just going to equal e to the 0 then, because this is true. Alright, so e to the 0, therefore the value of x, okay, the value of x equals e to the power of 2 over t is going to just tend towards 1. Alright guys, now for number 8 we've got the following question. The constant a, right, is such that the integral of ln x over root x dx between 1 and a is equal to 6. Okay, and it wants us to show that a is equal to e to the power of 1 over root a plus 2. Okay, so the way we go about doing this, okay, is we're going to say this: let u equal ln x, right? If u equals ln x, we can therefore say that du is 1 over x dx. Okay, and what I'm also going to say here is, so we're not really doing this via integration by substitution. We are kind of, but not in the way you'd think. Okay, so what I'm going to say here is x, let x equal e to the u. Alright, so with that in mind, okay, that's basically saying the same thing here. I can therefore say, well, if du is equal to 1 over x dx, I can therefore say that du is equal to 1 over e to the u dx. Okay, brilliant. So therefore e to the u du is equal to dx, right? So if we integrate between 1 to a of ln x over root x dx, we can say that according to our new parameters, we've now got ln a at the top, we've got 0 at the bottom. Okay, because x equals 1, therefore u must be equal to 0, and we can then say fine, that's equals to u e to the u over e over u to u over 2 du, which is therefore going to equal ln a at the top, 0 in the bottom, right, u e u over 2 du. Okay, perfect. Now we can do integration by parts. Okay, I'm going to do integration by parts. When we do integration by parts here, what I can say is let u equal u, let dv by du equal to e to the u over 2. Okay, so u equals u, dv by du is equal to e to the u over 2, right? So therefore The implication there is that v is going to equal 2e u over 2. Okay, so now we've just made this whole process 1,000 times easier for ourselves, right? Because now I can say that the integral of ln a at the top, 0, ue u over 2 du, okay, is equal to uv, so 2 ue u over 2, right, integrating between ln a and 0. Okay, I'm in this integral of ln a at the top, 0 in the bottom, 2e u over 2 du, okay? Perfect. Because v du, okay? So we've made this way easier for ourselves. Because now, what we've got is, we can say 2 ln a e, right, 2 ln a e to ln a over 2 minus 0. Okay, minus, and that's what this represents, minus minus 4 e u over 2, and that's going to be integrated between ln a, between 0 and ln a. Okay, so you integrate this, okay, it's 2e u over 2 divided by half, okay, so you just get the 4 there. Cool. Alright, so you can then say, alright, well, if we simplify this down, we get 2 ln a to the half, minus 4 a to the half, minus 1. Okay. 4 a to the half minus 1. Which we can then simplify further. We can say it's going to equal a to the half 2 ln a minus 4 plus 4. Okay, if we factorize this, right? So I'm going a bit quick, but if we expand and we factorize, that's what we'll get. Okay. All right. So the next bit is we can say that, okay, we found the integral. How much space we got? We found the integral the next step is to plug in. Okay, so if we plug in now, we get 8 to the half, 2 ln a plus 4 plus 4, that equals 6. Okay. Which means then, okay, if we take this down, we get 8 to the half, 2 ln a plus 4, okay, is equal to 2, Right. So we get what? We get 2 ln A. 2 ln A. So that should be -4 over here. It's quite a tricky question. Right, so we get 2 ln A minus 4 is equal to 2 over root A. Right, which means then that ln A minus 2 is equal to 1 over root A. Right, which gives me ln A is equal to 1 over root A plus 2. Right, ln A is equal to 1 over root A plus 2, which means that A is equal, okay, to E, 1 over root A plus 2. Okay, and that's going to be the final answer as required there. So that's quite a long question. So let's quickly go over how we did that. Right, the first thing we did was we kind of changed it up a bit and we used substitution. We use substitution first, and that's just to make things easier for us later down the line. Okay. With that, we then use by parts. Okay, we use by parts, plugged in our bounds, our new bounds. Okay, and we found our integral. Okay, which we then plugged into here to equal 6. And after that, we simplified and we got to the answer that they wanted. Okay. And alright guys, now for number B, we got the following question. Okay, it says verify by calculation that A lies between 9 and 11. Right, so how do we do that? How do we do that? Well, this is our formula, okay? A is equal to e to the power of 1 over a, root a, sorry, plus 2. So, we can say that, we can say consider f of a is equal to a minus e to the 1 over root a plus 2. Okay, brilliant. I can then say f of 9 is equal to 9 minus e to the 1 over root a, which is 3, plus 2. Right? What does that give us? Well, that gives us negative 1.31. Okay. If we do f of 11 now, we get 11 minus e to the 1 over root 11 plus 2, which equals 1.01. And so we can say that as f of 9 is smaller than 0, and f of 11 is greater than 0, right? That demonstrates that that A lies between these 2 points, okay? Because there is a change of sign, right? So we say therefore 9 to 11, and A is lying in between these. Alright, now for number C, okay, it's a classic iterative formula question, right? And I want us to determine a correct 2 decimal places. Okay, so very simple. There's not really much need to calculate each one. Well, you do obviously in the exam, but just for demonstration purposes, I've done it before. So I'm just going to go through it quick. We've got a n plus 1, okay, is equal to E over 1 over root 8n plus 2. Okay, we can say, well, A1 is going to equal what? Let's let A1 equal 10. And I've done that because we know it lies in between 9 and 11, right? And so 10 is the middle ground. Now if we use A1 is equal to 10, so therefore plugging that in, back in, comes to my calculations at 10.1374, which leads us to the following 1156. Okay, we plug this back in. Okay, plug it back in. Plug it back in. Keep it going. Okay, and our iterations have kind of curved over, right? They've stopped. So therefore we got 8 is equal to 10.1185. Perfect. Right, and that's the final answer to that question. Very simple, classic iteration question. This is a case of starting with one, a sensible estimate, which is what we got, plugging it in, and then it's replugging.